Hey everyone, ready for a deep dive into the future?
I'm ready.
Today, we're tackling agentic systems.
Sounds intense.
It is, but also super fascinating. We're talking about AI that can actually take action, not just crunch numbers.
Like AI that can make decisions.
Exactly. We've got a dense academic paper as our guide for this deep dive.
Okay.
But don't worry, we'll break it down into easy-to-understand pieces. By the end, you'll see why this tech has the potential to change, well, pretty much everything.
I'm all ears.
All right, so let's start with something familiar. SaaS. You know those software platforms we use every day?
Yeah, like for project management or email marketing.
Exactly. They're great for scaling up routine tasks. But this paper highlights a big problem with traditional SaaS.
No, what's that?
They hit a wall when things get complex, especially in specific industries.
Okay, I see where you're going with this.
Let's take e-commerce, for example. SaaS can handle your orders no problem.
Right.
But can it analyze customer behavior in real time to adjust your inventory?
Not really.
Or marketing. Automated campaigns are great, but what about reacting to a competitor's move on the fly?
Yeah, traditional sauce isn't built for that.
Exactly. And the paper talks about how even context-aware systems, while a step up, still fall short.
Interesting.
They use real-time data, but they can't make truly intelligent decisions. Imagine trying to manage your inventory,
Okay.
but your system is clueless about a sudden supply chain meltdown.
Yeah.
Chaos.
Right. Big problem.
That's where AI agents come in, specifically vertical AI agents. These are built for the unpredictable world of business.
Okay, I'm starting to see the difference.
They can handle those nuanced decisions that regular systems just can't grasp.
Vertical AI agents, it sounds like a whole new level.
It is. So what makes them so special?
They have three major advantages. First up, targeted domain expertise. Forget one size fits all. These agents are specialists in their field.
Like an AI consultant who's already an expert in your industry.
Exactly. No more generic algorithms trying to be a jack of all trades.
Love it. What's the second advantage?
Dynamic adaptability. Imagine a system that constantly adjusts to the latest data,
Okay.
market shifts, even the weather if it's relevant.
Whoa, that's next level.
That's what these agents can do. They're constantly learning and evolving.
That's wild.
Yeah.
Third big win.
End-to-end automation. They don't just analyze, they take action.
Oh, wow.
From raw data all the way to tangible results, they manage the whole process.
So brains and brawn, can you give us some real-world examples?
Absolutely. Picture a legal AI agent that analyzes contracts for risks and suggests revisions,
Okay.
way faster than any human lawyer. Or a healthcare agent that interprets medical images.
To help doctors with diagnoses.
Exactly, and even personalized treatments.
Those are some serious time savers, especially in fields where precision is key. And this isn't some distant future fantasy, right?
Not at all.
The paper mentions companies like Google, AWS, and Microsoft are already pouring resources into this tech.
Yep, it's happening now.
Okay, so let's get under the hood. How do these AI agents actually work? What's going on in those digital brains?
It all starts with what are called LLM agents. They're the building blocks powered by large language models.
Those LLMs you hear about everywhere.
Right. Here's a way to think about it. Imagine you need to get from point A to point B.
Okay.
A static LLM workflow is like following a fixed path. Great if there are no surprises, but what happens when there's a roadblock?
You're stuck, inflexible, can't adapt.
Exactly. An LLM agent, on the other hand, is like having a GPS and a live map. It can reroute, find shortcuts, adapt to whatever the journey throws at it.
That makes a lot of sense.
All right.
So LLM agents are all about flexibility and adaptability. But what gives them that incredible ability? What are the key parts that make them tick?
The paper breaks down an LL agent into 4 core modules. Think of them like different parts of the brain working together.
Okay, I'm intrigued. Lay it on me, module by module.
First, we have the memory module. This is where the agent stores all its past interactions, learned information.
Essentially, its entire knowledge base.
Right, like the agent's personal notebook.
Okay,
Then there's the reasoning engine. This is where the LLM really shines.
how so?
It allows the agent to plan, make decisions, and make sure its actions are logical.
So like the command center using the power of the LLM to make smart choices.
Exactly.
What about the third module?
This one's called cognitive skills. It's about giving the agent specific talents for particular tasks.
So it's not just general intelligence, it's having specialized expertise.
Exactly.
So our AI agent is getting a custom skill set. What kind of skills are we talking about?
It could be anything. Risk assessment, image recognition, compliance monitoring, you name it.
Wow, like assembling an AI dream team, each member with their own unique expertise. What's the final piece of this brain trust?
That would be the tools module. This is the agent's way of interacting with the outside world, accessing databases, APIs, other systems.
So it's not just thinking in isolation. It can actually do things in the real world. This whole architecture is fascinating. We've got these amazing LLM agents. But how are they actually put to work? What are the different kinds of agentic systems out there?
The paper outlines three main categories. First, we have task-specific agents. They're masters of one trade,
Okay.
highly efficient at handling specific
So
functions.
the specialists laser-focused on one key area. Got it.
Exactly. And then we have multi-agent systems. They take things up a notch. Imagine a team of these specialized AI agents all collaborating to achieve a common goal.
That sounds incredibly powerful, like a well-coordinated team of AI specialists tackling a complex problem.
Yeah.
What's the third type of agentic system?
The third type is what we call a human-augmented agent. This is where AI and human intelligence truly become partners.
Okay, that one definitely piques my interest. We'll have to unpack that further.
Absolutely. We'll dive into some real-world examples of all three types in just a moment.
All right, let's get into some real-world applications for these agentic systems. I'm really curious to see how these different types of agents play out in practice.
Yeah, let's dive into some examples.
Perfect. So let's start with those task-specific agents. The paper gives a great example called a RAG agent router.
RAG agent router, catchy name.
Right. So what exactly does it do?
Well, imagine you have tons of information stored in all sorts of different places, like databases, documents, knowledge graphs, everything.
Okay, yeah, I can see that being a challenge.
A RAG agent router is like a super efficient librarian who can instantly find exactly what you need.
No matter where it's stored.
Exactly. It goes beyond just keywords. It actually understands what you're asking and what you're looking for.
So it's like a search engine, but way smarter.
Precisely. And this is super useful when you have a bunch of different knowledge bases that are, specific to certain areas.
Okay, so paint me a picture. Give me a real-world scenario where this would be a game changer.
Think of a customer support system for a big company.
Okay, tons of questions coming in from everywhere.
Exactly. Customers might have questions about orders, returns, billing, tech issues, all sorts of things.
Yeah, a total mishmash of inquiries.
Right. And a RAG agent router could instantly analyze each question, figure out which department or knowledge base is most relevant, and then pull up the exact info to give a helpful answer.
Wow, that would streamline customer service so much. Instead of getting bounced around or digging through endless FAQs, customers get instant answers.
Exactly. Much more efficient.
I like it. Now, what about those multi-agent systems? The paper had that cool example of a RAG-orchestrated multi-agent system. What was that all about?
Yeah, that one is really cool. It shows how powerful it can be when multiple agents work together as a team.
So instead of one agent trying to do it all, it's more like a coordinated effort.
Precisely. Think of it like a team of experts with their own skills, all working together to solve a complex problem.
I'm picturing a team of AI detectives, each following a different lead.
Perfect analogy. In this case, the lead detective, or the orchestrator agent, would get a complex request, break it down into smaller tasks, and then delegate those tasks to specialized agents.
So each agent is responsible for finding information from a specific source.
Exactly.
Okay, I'm following. Walk me through a real-world example of this in action.
Sure. Imagine a financial analyst who needs to put together a report on a company's performance.
Okay, makes sense.
They need to analyze financial data, market trends, competitor activity, even news sentiment.
That's a lot to handle.
Right.
Yeah.
With this multi-agent system, the orchestrator would assign tasks to specific agents. One might analyze financial statements, another might pull market data, another scans news articles for sentiment analysis.
So it's like a whole team of AI analysts working in parallel, each focusing on their area of expertise.
Exactly. And then the orchestrator agent gathers all the results, puts it all together, and presents the analyst with a complete report.
Wow. That would save so much time and effort. No more manually compiling data.
Right. It lets the analyst focus on the higher level analysis and decision making.
I'm starting to see how powerful this could be. Now, what about those human-augmented agents? They sound particularly interesting because they involve collaboration between AI and human intelligence.
Yeah. This is where AI can really shine by enhancing human capabilities, not replacing them. The paper highlights the human-in-the-loop agent as a key example.
Human in the loop, that sounds intriguing. What's the idea there?
So in this system, the AI agent does a lot of the hard work, like analyzing data and making recommendations. But then a human expert reviews and validates those recommendations.
So it's like having a super smart assistant, but the final decision rests with the human.
Exactly. And this is really important for things that require ethical considerations or complex judgment or just plain human intuition.
Okay, give us an example where this type of system would be super valuable.
Sure, let's take healthcare. Imagine an AI agent helping doctors diagnose rare diseases.
Okay, that's a tough one for sure.
It can analyze symptoms, medical history, genetic data, and even research the latest medical literature.
To suggest possible diagnoses and treatment options,
Yes.
that would be a game changer.
But the final diagnosis and treatment plan would still be up to the doctor, who brings their experience and judgment to the table. The AI is just a tool to enhance their decision-making.
It's like a partnership where the AI expands the doctor's knowledge and capabilities,
Yeah,
but the human is still in control.
exactly. And the cool thing is that the system learns from the human's feedback. Every time the doctor validates or changes the AI's suggestions, it helps the AI become more accurate.
So it's a continuous learning loop, with the AI constantly improving based on the doctor's input. That's incredible.
It is. The paper goes into other examples too, like fraud detection in finance or legal document review.
Okay.
In each case, the AI agent automates the more tedious or analytical tasks, while the human expert provides the final validation and judgment call.
It's like a perfect division of labor, with AI and humans each playing to their strengths. These examples are really eye-opening. It's clear that these agentic systems have the potential to really transform industries.
Oh, yeah, absolutely. And it goes beyond just automating tasks. It's about reimagining entire industries. We've talked about healthcare, finance, law, customer service, but the possibilities are endless. Imagine AI agents managing complex supply chains, personalizing education, optimizing energy consumption, even assisting in scientific discoveries.
It's both exciting and a little daunting to think about the scale of the changes these technologies could bring. What are your thoughts on that?
Yeah.
It really makes you think about the future, both the positive and the potential downsides.
Absolutely. And as these systems get more and more complex, I think we really need to make sure they're developed and used responsibly.
For sure. I mean, we can't just get caught up in all the cool things AI can do without considering the potential consequences.
Right, exactly. That's why I think it's so important to have these kinds of conversations, to really make people aware of these technologies and encourage them to think critically about them.
Well, I'm really glad we took this deep dive into agentic systems. It's been fascinating. I feel like we're just at the beginning of a whole new era in computing where these intelligent agents will play a bigger and bigger role.
I completely agree. And as we move forward, I think the key thing to remember is that the future of AI isn't about machines taking over. It's about finding ways for humans and machines to work together to enhance each other's strengths and ultimately create a better world.
That's a great way to put it. Well, folks, that brings us to the end of our deep dive into agentic systems.
I hope you enjoyed it.
Yeah, we hope you found it as fascinating as we did.
And if you want to dig deeper into this topic, I definitely recommend checking out the paper we talked about today. It goes into a lot more detail.
And as always, we love hearing your questions and thoughts, so please keep them coming.
Thanks for listening.
Until next time.